Now to introduce our presenter for tonight's lecture. Ben Goldfarb is an environmental journalist whose work has appeared in National Geographic, The Atlantic, Smithsonian Magazine, and many other publications, and has twice been anthologized in the Best American Science and Nature Writing. His most recent book, Crossings: How Road Ecology is Shaping the Future of Our Planet, was named one of the best books of 2023 by the New York Times and the New Yorker, and received the Rachel Carson Award for Excellence in Environmental Writing and the Banff Book Competition's Grand Prize. His previous book, Eager: The Surprising Secret Life of Beavers and Why They Matter, won the Penn E.O. Wilson Literary Science Writing Award. Ben lives in Colorado with his wife, his daughter, and his dog, Kit, which is, of course, what you call a baby beaver. So at this point, I will turn things over to Ben to get us started. Welcome, Ben.
Thank you so much, Amy, for that introduction. Thanks for having me. Thanks to all of you for being here this evening. I so appreciate it. So tonight I'll be talking about my most recent book, which Amy mentioned, which is called Crossings, and is about the science of road ecology. And since that might be an unfamiliar term for many of you, it was to me when I began working on this book. Road ecology is basically this relatively small, but I would say very fast-growing field of scientific research that looks at how roads and really all of our transportation infrastructure transform the planet and our ecosystems. And I think most important, what we do about those transformations, how we manage the effects that roads have on nature. And roads are so transformative in large part because there are just so many of them, right? We have 4 million miles of road here in the US, around 40 million miles of road globally. And we're in this period known as the infrastructure tsunami. There's this wave of new construction that's sweeping the planet, especially in developing countries like Nepal and Myanmar and Honduras. So we're sort of slated to have another 15 million miles more of paved road, to say nothing of unpaved road, by the middle of this century. So there are a lot of roads out there. We're building more all the time. And I think in large part because we have so many roads, we don't really think about them very much, right? We use them every day. They're kind of the invisible, ubiquitous backdrop to our lives. And when we do think about roads, we think about them as being fundamentally useful, right? Roads are how we get to schools and hospitals and grocery stores and all the places we like to get to. We drive on them every single day, right? And here in the U.S. especially, roads have a powerful cultural connotation. You know, they're these symbols of freedom and mobility and momentum, that Bruce Springsteen sings about and Jack Kerouac writes about. And the tragic irony of roads is that for all of the mobility and momentum and freedom that they're providing us humans, they're denying other animals at truly a mind-boggling, almost incomprehensible scale. And the primary way that roads do that is through direct mortality, right? Road kill. Animals hitting cars. We've all seen the dead deer or skunk or raccoon by the side of the highway. And, often when I do talks in person, I poll the audience. I say, how many animals, vertebrate animals, so we're, not insects and arachnids, we're talking about birds, mammals, reptiles, amphibians, are hit by cars every day in the US. And somebody will say, maybe 10,000, or really on the high end, maybe 50,000 or 100,000. But in fact, more than 1 million vertebrate animals are killed by cars in this country every single day. And I think, in part because logically enough, the animals that get hit are the most common animals. We have this way of saying, maybe subconsciously, yeah, it's really sad that all of those squirrels and raccoons are getting hit by cars, but, there are a lot of squirrels and raccoons out there, right? So, it's sad for those individual animals, but it's not really a population level conservation crisis. But in fact, there are dozens of federally threatened and endangered species, from the Florida panther to the ocelot to the tiger salamander to the Hawaiian goose, for which cars are the leading source of mortality, right? These are species that we're literally driving to extinction. And in fact, as Richard Foreman, one of the founders of road ecology, put it, roads are actually the leading direct human cause of vertebrate mortality on land, which is just a fancy scientific way of saying that there's literally nothing that we do that kills more wild animals than drive. I think that one of the things that makes roadkill so pernicious as a conservation problem is the way that it subverts and really hijacks evolution, right? You think about the defense strategies of so many of our common beloved animals, from turtles who withdraw into their shells to porcupines who bristle their quills to skunks who spray, right? These are kind of hunker down, stand your ground defense mechanisms that worked really well for thousands of generations against coyotes and wolves and cougars and various natural predators. But when your predator is an F-150 barreling down I-90 at 80 miles an hour, the worst possible thing you can do is withdraw into your shell, right? So roadkill and really the modern weight and speed of vehicles takes evolutionary history and actually renders it maladaptive. And I find that really tragic to contemplate. So historically, now I'd say that road ecology has been again really largely focused on roadkill. It's its effects on populations and what we do to stop it. And we'll talk about that in a minute. But I should note that roadkill is really just the tip of the iceberg when it comes to how roads transform nature. And there are road ecologists all over the world thinking about these other connections and interactions as well. You guys are guests of an arboretum, so I think it's incumbent to at least mention plants, right? As you probably know, roads are vectors of invasive species. We've all seen dandelions lining the highway, right? So many non-native plants and animals enter ecosystems effectively along a grid. One of the places I went working on this book was Montana, where there were these old dirt logging roads. And for many decades, logging trucks have been transporting the seeds of invasive thistles and other plants in the treads of their tires. And then after a big rainstorm, all of those thistles kind of bloom at once. And then there's this eerie, linear purple stripe running across the landscape. Roads are zones of erosion. Who's the single largest road manager on Earth? It's not the Federal Highway Administration. It's actually the U.S. Forest Service, which manages something like 400,000 miles of road on public lands in the U.S. The vast majority of them, dirt logging roads. So they're not, they see, a dozen cars a year. They're not roadkill risks, but, they're geological and hydrological risks. You get a big rainstorm or a snow melt on those dirt roads, and they basically turn liquid, and all of that sediment runs off into lakes and streams and rivers, and smothers fish eggs and amphibian larvae and impacts downstream water quality. So just because a road isn't well trafficked doesn't mean it's not transforming the landscape at a really massive scale. Roads are sources of pollution. Our cars are constantly bleeding cadmium and zinc and copper and microplastics and all of this crap into the environment at all times. And we're learning more about those chemical connections all the time. A few years ago, scientists at the University of Washington did a bunch of research, and they realized that these salmon die-offs that had been occurring for many years were being caused by 6-ppd, which is an obscure chemical nobody had ever heard of, in tire particles. And 6 million tons of tire particles enter the environment every year and turn out to be killing fish on a truly massive scale. One of the most powerful kind of chemical connections that roads create is through road salt. We add 20 million tons of road salt as a de-icing agent to our highways every year here in the US. And all of that salt has to go somewhere, right? And so it runs off into rivers and lakes and streams and wetlands, which in many places are turning more and more brackish over time. We're also creating these really dangerous situations, right? By luring animals to the highway side to lick up that salt. We know that animals love salt, and so we're creating these really dangerous interactions. We're basically turning our highways into these linear salt licks. I will add that the road salt issue did inspire my favorite road sign. This is in Jasper National Park in Canada. Every winter, you can see signs saying, "Do not let moose lick your car." I'm not sure that you could stop a moose from licking your car. I think if he wants to do it, he's probably going to. But it's the sort of weird, novel interaction that roads can create. Roads are also these hellscapes of noise, right? Imagine being a Western meadowlark who has to sing to attract a mate. Well, if your mate can't hear you over the constant noise of engines and tires, you fundamentally can't live in that place, right? So in that sense, road noise is a form of habitat loss. Animals live in this very sensitive acoustic world, and if the signals and cues they need to survive are being drowned out constantly, that's not a hospitable environment. So a road might only be 100 feet wide from shoulder to shoulder, and yet that acoustic shadow that it's casting, can span a half mile or more in many cases. And I wanted to play one quick video that I think illustrates this concept of road noise as habitat loss, because it's not necessarily an intuitive one, but I think it's a really important one. So here we've got a couple of bears right wandering through the forest, a lovely sylvan scene. And then suddenly that that ATV noise comes in, right, and chases those animals out of that habitat. And I should add that in this case, there actually was no physical vehicle. There was no road. There were just researchers playing road noise or engine noise through a speaker. But again, that acoustic disturbance was enough to drive those animals out of that habitat. So this all sounds really bad, and it is, but it's not just doom and gloom, right? Yes, roads destroy ecosystems, but there are also ecosystems in their own right. Animals are endlessly creative and adaptable and flexible, and they're really good at taking advantage of the novel concrete habitats that we engineer for them. One of the places I went in working on this book was Minnesota, and I visited this big highway overpass. And on the underside of the overpass were all of these concrete grooves, and there were hundreds of little brown bats roosting in those crevices, again exploiting that habitat that we'd inadvertently created. Another really good example of roadside habit of roads creating habitat are roadsides, right? In many states, especially in the Midwest, roadsides are actually the largest form of public land. The rest of the landscape is corn and soy monoculture, and those roadsides are the only strips of prairie remaining to monarch butterflies and other insects. These days the famous Midwestern monarch migration basically follows I-35 from Minnesota to Texas. There are hundreds of millions of milkweed stems, lining our highways. So that's promising, certainly, that animals can find sustenance along the road, but it's also dangerous, right? Obviously, the road is a perilous place to be, and millions of monarch butterflies are actually killed by cars, during their migration every year. We don't really think about insects as being roadkill, but this is again, an immense source of mortality. So we always have to be thinking, are our roadsides producing more monarch butterflies or bumblebees, than they're killing, right? And what can we do to manage or mitigate those interactions? I've heard, DOTs propose planting milkweed further back from the shoulder, or actually elevating plantings on berms so that butterflies are flying over traffic rather than through traffic, right? Or changing mowing or burning schedules along roadsides so that you're kind of optimizing milkweed growth when those monarch caterpillars most need it. But again, I guess the point is that the road is this ecosystem, but it's also an anthropogenic ecosystem that we have to be really thoughtful about managing. And that goes for scavengers as well, right? We've again kind of inadvertently created these linear carcass trails through the landscape that really get utilized by coyotes and ravens and magpies and bald eagles and golden eagles. Here in the West, especially those golden eagles, in winter, all of those dead deer and elk and antelope are a really critical food source. But again, a very dangerous food source. If you're an eagle with a belly full of venison, it's hard to achieve liftoff, and you're at risk of being hit by a car yourself. And thousands of eagles actually get hit by cars every year. Uh, there's some great research by a group called Hawkwatch International, which basically found that if you assigned road crews to driving around and just taking those carcasses and dragging them 40 feet off the highway. That's kind of the magic number. You drag that carcass 40 feet into the surrounding scrub, and that's basically the distance at which eagles can feed in peace without, without being at risk of being hit by a car or constantly flushing when an 18-wheeler drives by. So again, we can take that tragedy of roadkill and manage it in a way that it becomes a resource as well. I think it's important to note that, all of these animal vehicle collisions aren't just dangerous for deer and coyotes and eagles. They're also really dangerous for us drivers. Wildlife vehicle collisions, WVCs, as the jargon goes, are really, I think, a dramatically reported public health and safety issue. Every year, there are up to 2 million annual collisions with large animals. Here in the US, that's a collision every 30 seconds, which means there'll be dozens while we're having this conversation. These days, the average deer crash it costs more than $9,000 to the public in hospital bills and vehicle repairs and insurance costs and tow trucks and so on. And more than 400 drivers are killed every year in deer collisions. And that's I would say, again, a dramatic underestimate, right? I've talked to state troopers who say, look, a lot of fatal single car crashes are probably wildlife related. Somebody swerves to avoid a deer, hits a tree or a telephone pole, unfortunately doesn't survive to tell the story, doesn't get reported as a deer collision, but was certainly wildlife related. So again, this is an immense public health and safety issue that's killing hundreds of people and costing society billions of dollars, around $10 billion every year in damages. So historically, the way that transportation departments have tried to solve this problem is through this thing. We've all, seen this yellow diamond with the leaping black buck a gazillion times. And I'll just tell you empirically what I bet you've deduced intuitively, which is that these things really don't work, right? We put them up all over the place without much rhyme or reason. Drivers totally habituate to them, ignore them. Often you see this sort of thing, deer crossing next 30 miles, right? What driver is going to remain on high alert with her, foot on the brake for 30 miles? Of course, nobody. And the deer don't know to cross at the signs. That's really frustrating, right? So I've actually heard biologists call signs litter on sticks, which I think, gets at their uselessness nicely. And I'd point out too that, even if signs were effective in reducing animal collisions, from the wildlife's perspective, the collision is only part of the problem or half the problem that the road creates. And, in some cases, I would say an even bigger problem is what some researchers have called the moving fence, this kind of wall of traffic that vehicles create, and the habitat fragmentation that goes with that. Right, we've all had the experience of standing on the side of a busy street, waiting for a gap in traffic, and having to scurry across between cars, to get from one side to the other. We know how scary and dangerous those interactions are. Now imagine, being a deer or some other black bear who has, sort of no concept of exactly what a vehicle is. And you can imagine that, many animals elect not to cross the road at all, right? That wall of vehicles is just too constant and impenetrable and frightening to them. And I would say that, for some populations, in some cases, that habitat fragmentation created by these walls of traffic can be a bigger problem, actually, than roadkill itself. And so one of the places that I went to kind of understand that concept was southwestern Wyoming. Basically, Southwest Wyoming has a big population of mule deer. Mule deer are, kind of the close sister species to the white-tailed deer that, you're all familiar with in the East. And these deer are really migratory. They walk 300 miles round trip, this one herd of deer, from their winter range to their summer range up in the mountains and then back down to the valley. And that's great, except the problem is that I-80, a highway that certainly Pennsylvanians are familiar with, runs right through the middle of that winter range, right? And so those deer, and you can see this on this map very clearly. This is a map of where those deer hang out in winter based on data from the satellite collars that the scientists have put on them that you can see in this picture. And what those satellite collars have revealed very clearly is that those deer just never cross I-80, right? And during harsh winters, they'll basically pool up on the north side of the highway looking for a gap in traffic that never arrives. And that's a problem because a lot of the really good habitat, the good winter forage is south of the interstate, but they can't get to it. So during some harsh winters, up to 40% of that herd will actually starve to death. Again, those aren't animals that were hit by cars, right? Those are animals who died because they couldn't cross the highway to reach the habitat on the other side. And, again, I think that's probably a bigger issue for those animals than roadkill. A herd of 1,000 mule deer can handle a few collisions on the highway. What they can't handle is losing access to all of that habitat. Here's another map that I think illustrates a similar point. These are the movements of a single young male grizzly bear in Montana. That white line is I-90, and every red X is a place where that bear approached the highway and bounced off like a ping pong ball, just repelled by that moving wall of traffic. And that bear attempted more than 40 crossings before he finally found his way through on the far left side of the screen. So you can just, again, imagine being that bear, right? There are thousands and thousands of acres of good habitat that you can see, on the other side of the interstate. And yet this very narrow strip of asphalt prevents you from getting there. Here's another, kind of depressing map. I sort of love these because they just tell such powerful stories. These are the locations of individual mountain lions in Southern California, just outside of Los Angeles. This is the Santa Monica Mountains. If you've heard of the mountain lion P22, this is where P22 lived, very famous cat. Those red lines, of course, are the freeways. The 101, the 405, busiest freeways on Earth, trafficked by hundreds of thousands of cars per day. And what you can see very clearly again is that those mountain lions basically never cross those freeways. And that's a problem because they're basically trapped in this little island of habitat, and they can't disperse out to establish their own territories. And just as bad, no new mountain lions can disperse in across the freeway to refresh the gene pool and breed with those cats. And so these mountain lions are basically stuck mating with their own relatives. There have been individual cats who have bred with their own daughters, granddaughters, and great-granddaughters. They've begun suffering genetic defects. They're increasingly inbred, and they've entered what scientists have called an extinction vortex, this kind of long-term doom spiral created by habitat fragmentation. So we've got these two related problems, right? We've got these wildlife vehicle collisions, all of this roadkill, which is a huge threat to animal populations and also a really big danger to us drivers. And we've got this habitat fragmentation problem, right? The fact that animals can't cross the road to access the resources that they need to survive. So how do we solve those two related problems? And really the best tool at our disposal are wildlife crossings, overpasses, underpasses, culverts, all of these different structures that are basically designed to let animals get safely from one side of the road to the other. And this idea of building kind of dedicated infrastructure for animals really dates back to the middle of the 20th century. In France. France was the first country to do this sort of thing for deer in the 1950s, followed shortly by Germany and Switzerland and other Western European countries. These days, the Netherlands is the world's leader in wildlife crossing construction. The Dutch are just famously great engineers at everything they do, right? So here's a famous Dutch overpass for badgers and other critters that crosses two highways, a railroad track, a sports complex, and a business park, a kilometer-long overpass, only part of which you can see in this picture. So pretty cool structure. Here in North America, the place that wildlife crossings really took off was in Banff National Park. And, I'm sure some of you have been to Banff, and you know that, like many quote unquote protected areas, it has a highway, the Trans-Canada Highway, running right through the middle of it. So lots of animals, of course, were killed. And in the 1980s, Banff began building first a number of underpasses, followed by around a half dozen overpasses, like you can see in this picture. And the overpasses were really for one critter in particular, the grizzly bear. Grizzly bears are these big, powerful animals. They don't want to be, slinking through a culvert. They want to be up on the deck of a bridge so they can look around and, look out for enemies, generally other bears, and use their kind of power and strength and speed out in the open, right? So bears really, grizzly bears in particular, really have a strong preference for overpasses, whereas, the black bears that, you're all familiar with, tend to be happy, relatively happy using underpasses because they're sort of more forest dwellers who are a little bit more accustomed to being in tighter quarters. But grizzly bears really have a strong preference for overpasses. So at the time that these overpasses were built in the 1990s, nobody really knew whether this was going to work. The crossings that had been built in Europe hadn't really been very well studied, so nobody was totally sure whether bears would actually use these things. And it took them a few years to habituate to them, but sure enough, after a few years, the grizzly bears really did get comfortable on these wildlife crossings, and the sows, the females would go back and forth. They'd mate on either side, so they're just stirring up that gene pool. They would teach their cubs to cross, and their cubs would become crossers. So there's this really cool intergenerational learning process that happened, and about 20 years of research showed, I think, very conclusively that that kind of genetic fragmentation that you see in California's mountain lions, really doesn't occur with Banff's grizzly bears, that they're able to go back and forth across the highway safely using these crossings. And so, this was really the place and the research that kind of popularized this concept around the world. And now every road ecologist on the planet has been to Banff National Park to see the overpasses that kind of started it all. Here in the U.S., wildlife crossings really date back to the 1970s. The first were built in Colorado, where I live, Wyoming, Utah, really these intermountain west states. And the reason for that is that in these Western states, our wildlife tends to be really migratory. We get these large numbers of deer, elk, antelope, moving in big herds along very consistent pathways between seasonal resources year after year. And so, if a herd of 1,000 deer crosses, the same highway in Wyoming every single year, pretty soon there's this big pile of carcasses saying, hey, put a wildlife crossing right here, right? So those Western migratory ungulates, those hoofed mammals tend to be pretty easy animals to mitigate for, whereas, in the East, it kind of feels like white-tailed deer like everywhere all the time, right? There aren't really consistent migration pathways, which is why historically eastern states have sort of thrown their hands up and said, this is fine for those guys out west, but we don't really do this here in the East. But that's starting to change, and we'll talk about that in a second. I think a really important lesson, maybe the most important lesson that road ecologists learned over time, or very quickly, I would say in many cases, is the importance of fencing, right? People always say, how do the animals know to use the wildlife crossings? How do they know the crossing is there? And basically the answer is you fence off that highway and you make them use it, right? That deer is trying to get from the north side to the south side, and he hits that fence line. He, paces the fence line for a quarter mile looking for an opportunity to get across. And then all of a sudden, here's this, this big, beautiful box culvert saying, hey, cross right here, right? So those two elements, the crossings and the fences, really go hand in hand. The fences keep the animals off the highway and funnel them to the crossings, and the crossings allow them to, connect those habitats. You really can't have one without the other. Another important lesson that I think road ecologists have learned or are still in the process of learning in some cases is the importance of providing a diversity of crossing types and opportunities, right? We know, of course, that all animals fill different ecological niches and have different crossing requirements, and likewise they have different or they have different habitat requirements, and they have likewise different crossing requirements, right? Some animals are very content going under highways. Some really prefer to go over highways. Another example of an overcrosser here in Colorado is pronghorn, antelope, the fastest land mammal in North America. Those are again not animals who want to go through a tunnel. They want to be up on a bridge so they can run away from a wolf or a mountain lion if they have to. So you have to always be thinking about sort of the needs of the species that you're trying to help. Here's a really nice example of that. This is an overpass on I-90 in Washington, just outside of Seattle. The overpass is really for elk. Elk tend to have a strong preference for overcrossing, but it's not just elk, right? They've also got fence lizards and western toads and rodents and all of these other smaller critters that want to get across that overpass as well without being picked off by a hawk. And so this is the Washington State DOT, installed all of these log structures on the overpass, what they call faunal furniture. So basically, if you're a meadow vole trying to get from one side to the other, you can kind of hopscotch between those downed logs and make it safely across. Another, sort of nice example from that same stretch of highway, I-90 in Washington State. Here's a big kind of capacious underpass. You can see that they actually split the lanes of traffic so that light, can penetrate and hit that underpass floor and just create a much more natural, appealing vibe. You can see more log structures in place, as well as a line of rocks running through the back of that underpass, and that's for reptiles and even pikas, little talus-associated mammals who want those rock lines to kind of scamper through. So again, just thinking about the whole ecosystem. Another nice example from that same stretch of highway is this big box culvert. Historically that little stream flowed through one of those corrugated metal pipes that we've all seen a million times, and that's obviously not ideal for animals, although they do use it sometimes. So they tore out that narrow culvert and then just put in a bigger box culvert. So that gets used by otters and beavers and salamanders and of course fish and all kinds of critters. So those culverts, I think it's worth taking a second to just talk about those because they are suboptimal for wildlife in many cases, but they're also great opportunities, right? Here in the US, we have something like 2,000 dedicated wildlife crossings, which, sounds like a lot, but, really that's one every 2,000 miles of road. So not too many in the grand scheme. We've got about 2 million culverts, right? Everywhere a stream or a creek or a wetland goes under a highway, there's a culvert. And animals have, in some cases, learned to use those culverts as kind of de facto wildlife crossings to scamper through. And there are things we can do to help them to take those pre-existing culverts and make them more effective wildlife crossings. So here's one example of that. This is a culvert under Highway 93 in Montana. This pipe gets used seasonally by all kinds of critters, bobcats, weasels, skunks. The problem is that in spring, the water comes up and that culvert is partly flooded, and those animals don't want to get their paws wet. So what the DOT did in this case was they actually put what they call a critter shelf, that steel catwalk that you can see that runs the length of that culvert. So now animals can use that even when there's a few inches of standing water at the bottom of the pipe. So I think that's a really important point, right? Not every single wildlife crossing has to be some big, beautiful $10 million, bridge for bears. There's a lot we can do with cheap tweaks and retrofits and modifications. We can take our existing infrastructure and render it more wildlife friendly. And here's a really nice example of that. I said earlier that the eastern states have not historically been as proactive about building wildlife infrastructure as the western ones, but that's starting to change, and the east is really catching up. And one of the states that's figuring that out is Virginia, a state with one of the highest deer collision rates in the country. And so what Virginia did a few years back is they had these culverts under I-64, very high white-tailed deer collision section of highway. And there are a couple of culverts there that were not built for wildlife usage, right? They were built for the seasonal passage of water and livestock. But the DOT basically said, wait a second, if we just build fences on either side of these pre-existing culverts, we can basically guide the deer and the bears and the foxes and the opossums to these culverts and turn them into functional wildlife crossings. And so that's what they did, right? They built a couple of miles of fence on either side of these pre-existing culverts. They saw more than a 90% reduction in deer collisions on this section of highway. So just keeping the deer off the highway, right? That's good. They saw a fourfold increase in deer usage of that culvert, right? So again, you're just making deer go through it, and the deer, figure it out and say, okay, this is where I'm supposed to cross. Great. And I think most relevant maybe for the DOT is that they actually recouped the costs of this project in under 2 years, right? We were talking earlier about how dangerous and expensive deer crashes are. Well, if you can build infrastructure that prevents dozens of these collisions every single year, you can actually pay for your own operations really quickly, right? You can save the public a lot of money. And I think that's a very important point about wildlife crossings generally, is that, sometimes people have a bit of sticker shock, when they hear the price tag for some of these projects. Really, we're going to spend, $5 or $10 million helping deer or black bears cross a highway. That sounds kind of frivolous, right? A little bit crazy. But again, because this infrastructure is making roads so much safer for human drivers, it is in most cases paying for itself very, very rapidly, often in under a decade. Here's an overpass on Highway 9 in Colorado, not far from where I live. This is an overpass on deer and elk winter range that gets used every day by animals, has dramatically reduced roadkill. And this is, a multi-million-dollar project that has paid for itself and then some. Of course, there's a kind of a caveat to that, which is that if we take an entirely cost-benefit focused approach to wildlife mitigation, there are a lot of animals that we leave out, right? And I think that's generally what's happened in the US to a large extent is, we've built lots of wildlife crossings for deer and elk and bears, kind of the big mammals that really mess your car up when you hit them. Meanwhile, nobody's ever totaled their car hitting a northern red-legged frog, right? So we haven't really built too many wildlife crossings for amphibians. And yet, those amphibians are some of the most road endangered animals on Earth, right? They're undertaking their own migrations in spring, coming up pretty soon here in the Northeast. Those first warm, wet nights, right? They're moving from their upland habitat to their wetland, breeding areas. And the problem is that, roads generally lie between those two habitats. And, frogs and salamanders, not the smartest animals in the world, unfortunately. They don't really know what a road is. And, they're really prone to getting squished en masse. So, yes, let's build more animals for those those large mammals where the crossings pay for themselves. But we also need to take a conservation focused approach and mitigate for those smaller critters too. And I'll just say that where we've done this, it works really well. Here's a beautiful amphibian culvert in Moncton, Vermont, that gets used by thousands of wood frogs and spotted salamanders and other amphibians, as well as some bobcats and kind of small to mid-sized mammals every single year, right? So we know how to do this. It's just a matter of summoning the political will to care about those smaller critters too. And of course, we just need, more wildlife crossings in more places generally. I was talking about those mountain lions in Southern California that are so fragmented and inbred due to freeways earlier. And as many of you probably know, there's a wildlife overpass being built for those cats right now that will be ready for their usage as well, along with bobcats and coyotes and lizards and other animals, starting later this year. And this is it can be the largest wildlife crossing in North America. It crosses the 101 freeway, 10 lanes of traffic, 300,000 cars a day. Uh, well, if we can build a wildlife crossing there, we can build one anywhere, right? I sometimes hear people, from the East Coast especially say, listen, we're just too densely populated. Our freeways are too big. They're too well trafficked. It's fine for some, rural road out in Colorado, but, it doesn't work, for I-80 in Pennsylvania or where have you. But if you can build a wildlife crossing over literally the busiest freeway in the country, right next to Los Angeles, right? These technologies and solutions are viable anywhere. And I'll say too that I've been talking a lot about American examples of wildlife mitigation, but this is really this very large global movement that we're a part of, and in some cases I think that the really exciting action is happening elsewhere. Here's a fabulous bridge built for red crabs on Christmas Island. These crabs are migratory, like amphibians. They're going from their kind of upland rainforest habitat down to the beach to spawn, and there's a road that runs between those habitats, and so they actually built this amazing kind of steel catwalk that the crabs hook their little feet, or not feet exactly, but legs into, and climb up, right? So that's the kind of compassionate, holistic, total ecosystem mitigation that we see in other countries. Another thing that we see in a lot of places are canopy crossings, right? These rope bridges that get used by, this is a squirrel glider in Australia, a little arboreal marsupial. You see this for howler monkeys in Brazil, and other primates in Kenya. And just I mean, these are animals who, again, they're kind of living up in the treetops. They're not going to descend to the forest floor to use an underpass. But if you connect those treetop habitats with some rope bridges and ladders, they'll very happily go back and forth. And we have animals here in the U.S. that would happily use this sort of thing, right? We've got fishers and flying squirrels and porcupines and all kinds of arboreal or semi-arboreal animals. We just haven't done it because, again, we're thinking a little bit myopically sometimes, I think, about the large mammals. The other challenge that we're up against is that we have this very calcified pre-existing infrastructure, right? We built our interstate highway system back in the 50s, 60s, 70s before we really knew the impacts that it was going to have on the environment. Whereas other countries, which are building out their infrastructure now, have an opportunity to learn from our mistakes and do it right from the get-go. So here's an example of that. This is a spot in India. India is, one of the fastest developing countries on Earth, of course. Building lots of new roads through wildlife habitat, which isn't great. Not what you'd want ideally, but they are at least in some cases, trying hard to manage those impacts. So here's a spot where new highway runs through a tiger sanctuary, and what they did was actually elevate the entire highway for many, many miles on these big concrete pillars, so that instead of having an isolated underpass here or there, the entire forest floor is wide open and animals can just go back and forth at their leisure. So again, when you do this sort of thing from scratch, you can kind of learn from the mistakes that we made here in North America and get it right the first time. Another country that I went to working on this book, where I found a lot of inspiration was Brazil. Brazil is, again, very fast developing country. They're paving lots of dirt highways and building lots of new highways. They've got lots of wildlife crossings for tapirs and anteaters and pumas and all kinds of critters. But to me, the coolest thing about Brazil is actually the legal framework they have around wildlife crossings, where basically what they say is that, if you're driving down a highway in Brazil and you hit a tapir and total your car, the road operator is actually liable for those damages, right? Not the insurance company, but the road operator, on the grounds that, hey, this is a problem that we know how to solve, and you should have built fences and wildlife crossings in that place, just like filling potholes, part of your job as a road operator should be making the highway safe for motorists and animals alike. So I just love how that takes the usual logic around roadkill and kind of inverts it, right? It says, this is not the fault of the driver. This is the fault of the infrastructure and its design. This is an infrastructural problem that we know how to solve and should be solving. So here in the U.S., it is a really exciting time for wildlife crossings, at least theoretically. That as some of you possibly know, the 2021 Infrastructure Act, included $350 million for new wildlife crossings. Some of that money has gone out the door. A lot of it went to Western states that know how to do this well, but increasingly we see states like Pennsylvania, Massachusetts, New York, even Midwestern ones like Missouri and South Dakota receiving these federal grants as well, to start doing some of the planning around these crossings, figure out, okay, here's where our, deer collision hotspots are. Here's where we should be building moving forward. Of course, the challenge is that, the Trump administration has, been very hostile to this program. Generally, some of the grants have been released, in the last year. Others are some have been canceled. Some have been kind of held up inexplicably. So unfortunately, we're in this very liminal moment right now for these projects. There is some really cool bipartisan effort right now in Congress to authorize a lot more money for wildlife crossings. There are bills in both the House and the Senate that would help a lot, would basically provide $200 million a year for new wildlife crossings, which would be, fabulous. So I would encourage you all to keep an eye out for those bills and, and encourage your elected officials to support them when the time comes, because, we certainly need funding for this. Um, and I'll add too, because I just love fish and think about them a lot. Fish need safe passage as well, right? Again, all of those corrugated metal pipes, those culverts are just, places that really impede fish migration. Again, we don't really think about fish crossing roads, but they've got to get under roads, just like bobcats and coyotes do. And so there's also, there's this another big federal culvert replacement program that funded projects like this one, tearing out those narrow corrugated metal pipes and putting in these bigger box culverts that allow salmon, like the one in the bottom left corner of the screen, to safely navigate. And, a lot of those grants went to eastern states as well for shad and herring migration. But again, those culvert replacement projects are also, in limbo right now. So again, theoretically an exciting time for these projects, but a lot of sort of political finagling. So, ultimately the opportunity and the challenge before us is to, remake our infrastructure to save biodiversity, right? No pressure. But, we know that we're in the middle of, this sixth mass extinction event in our planet's history, and that, roads are one of, if not the leading direct cause of that. And if we're going to save wildlife and biodiversity in this century, we have to think about our infrastructure. And here's an example of that. This is an underpass in South Texas. And South Texas is home to the last ocelots in the United States. There are about 100 ocelots in Texas. And road collisions are 40% of ocelot mortality. So that's a species that we're losing right now from this country because it can't safely cross highways. And I'll add too that that thinking about our roads, more holistically is also important for our own health and safety and flourishing. We get hit by cars too, unfortunately, in catastrophic numbers, and we're vulnerable to air pollution and noise pollution and community fragmentation. Amy mentioned before that she's from Syracuse. She was telling me that before before we got on. And so here's a highway that Amy probably recognizes well. This is I-81 running through Syracuse, Syracuse, New York, which was built in the 1950s, very deliberately through Syracuse's largest Black community and displaced thousands of people. And today, Syracuse is one of the most segregated cities in the country because it has this concrete wall running right through the middle of it. And you could tell the same story about Miami or Minneapolis or LA or Buffalo or many other American cities that have urban freeways running through the middle of them. But very excitingly, Syracuse is in the process of basically figuring out how to tear this thing down. Take down this viaduct Route I-81 around the city and replace it with an at-grade boulevard with housing and small businesses and churches and other community elements, right? So, I think the point is that, this infrastructure need not be permanent. We see roads and they look like the most permanent features on Earth. They're these concrete strips that it's hard to fathom ever rethinking or reimagining them, and yet all over the country we're in the process of doing that, both for communities and for wildlife. So, if any of this conversation sort of piques your interest, I do have this newish book out on the subject. Both the New York Times and the Wall Street Journal loved it. So there you go. There's liberals and conservatives, united around the niche cause of habitat connectivity. And I say that somewhat facetiously, but here in Colorado, where I live, 85% of residents support more wildlife crossings, and you couldn't get 85% of residents to agree that the sky is blue, right? So this is this issue that unites hunters and the Humane Society and all factions of our culture, and it's truly this, I think, unifying issue in a hyper-polarized society. So with that, I think we've got a few minutes for questions. Thanks again to all of you for being here, and happy to address anything that I didn't in the presentation.
Thank you so much, Ben. All right. So we are going to launch into questions. So again, if you guys want to put your questions in the Q&A section, if they land in the chat, I'll keep an eye on that as well. So this question is, does road noise discourage animals from using overpass and underpass crossings? Is there anything that can be done about that?
Yeah, it's a great question, and the answer is yes, it can. On busy freeways, certainly road noise and also light pollution as well. Those headlights are definitely a disturbance, and there has been some research showing decreased use of crossings in really noisy, bright areas, and so what wildlife crossing designers are doing now in some cases like that, and this is really top of mind for that mountain lion overpass outside of LA, because that's such a loud, bright, busy freeway, right? So they're installing all of these elements like berms and rock walls and vegetated screens that basically shield animals from the noise and light of the freeway. And you obviously, you're never going to make it totally quiet and dark, but you can kind of protect those sight and sound lines to some extent, and basically mitigate some of the sensory pollution that way.
You mentioned pollution caused by tire particles. Can you expand on that? Is there anything that can be done about this issue?
Yeah, so it's funny you mention that, because that's kind of being litigated right now. So the pollution and the pollutant in question is called 6-PPD. It's basically this chemical that's added to tires as an ozone protection agent. And turns out to be behind these big fish kills in Washington. So yeah, there's right now there's basically a lawsuit, a class action suit by commercial fishermen in California against the tire manufacturers, which that trial basically ended last week, I think, and now it'll be decided at some point this spring, and that could potentially force tire manufacturers to figure out an alternative. A couple of states, Washington included, have actually tried to have introduced legislation that would require tire manufacturers to replace that chemical. that legislation hasn't passed, but hopefully it will at some point. And meanwhile, I think the tire manufacturers generally recognize that sooner or later they're going to have to get rid of 6 ppd, and so I know there is active research into figuring out an alternative.
This question is, what about the southern border? Do you know of anything being done to allow animals to pass between Mexico and the US border as walls go up?
Yeah, so as the I mean, and I think that first, I mean, we should just say that obviously that the wall is a complete ecological catastrophe, that is this immense fragmenting disaster for jaguars and ocelots and and mountain lions and all kinds of critters. So, certainly just a crime against nature and humanity in my view. They are installing what they call like dog doors, and when I say they, I mean Border Patrol. They put in these little they do put in these little cutouts. They're basically like the size of a sheet of paper. They're like, I think they are exactly 8.5 by 11. And so they have put a number of those into the wall. The last issue of National Geographic actually had a kind of a cool photo essay depicting javelinas and coyotes and even one mountain lion somehow squeezing through one of those little apertures. So they do get used by wildlife to some extent, but there aren't nearly enough of them. They're certainly not big enough. That wall. I mean that we don't really have jaguars in the U.S., right? And a jaguar certainly couldn't use that one of those little doggy doors. So yes, they are. Border Patrol is theoretically putting some wildlife accommodations into the wall, but I would say not nearly enough to to actually deal with the fragmentation that it's causing.
Sure. Thank you for answering that. Are there a lot of biologists, scientists who study road ecology? And is this study included in engineering plans?
Yeah, it's a good question. I mean, certainly, well, I would say a lot. Certainly a lot. Well, yeah, I mean, I guess, what does it mean what does a lot mean? I guess is the question, right? I mean, certainly a lot more than did 20 years ago when nobody knew what road ecology was, right? It's not an official course of study. You can't get a PhD in road ecology anywhere, as far as I know. But it is. I mean, it is kind of a cool cross-disciplinary field. You see lots of ecologists, wildlife biologists, aquatic biologists. Because roads kind of touch on all of these different subjects. Lots of botanists interested in in roadside planting and mitigating the spread of invasive species along roads and that sort of thing. So yeah, I would say there aren't too many people out there who self-define as road ecologists necessarily, but I think that there are lots and lots of ologists in other fields whose work intersects with roads and have done some road ecology coursework and research, and that includes the engineers too. That's a really good point, because historically I would say that engineers just thought their job was to get the traveling public from point A to point B as quickly and cheaply and safely as possible, and now increasingly they recognize that this really is a that they can't engineers can't run from the impacts that their infrastructure is having on nature. And so now, you go to, one of these road ecology conferences, and I've, been to a million of them, and, the engineers aren't the majority, but, you definitely see some engineers there who are interested in learning more because, also in many cases, like they're just legally obligated to do this stuff, right? If you're rebuilding a highway in South Texas and that highway, runs through ocelot habitat, well, the Endangered Species Act says you have to put in some ocelot accommodations, right? And so, even if engineers don't necessarily want to, have to worry about this stuff, they're often mandated to.
Mhm. So just kind of expanding on that as far as like a thinking of it coming, I guess, as a like resource minded. We know
Yeah.
obviously your book is an amazing resource for folks to learn more. Are there other books or organizations or websites or things that, places that people can go to learn more about road
Yeah, certainly. I
ecology?
mean, absolutely. Yeah. I would say, lots of different organizations, sort of touch upon this work in some way. I mean, two who I often shout out are Wildlands Network. And the Center for Large Landscape Conservation. Those two groups are both doing a huge amount of research into these issues, and also a huge amount of kind of policy and legislative work. Writing the legislation that then gets passed to fund these crossings, or figuring out alternative pots of money in states transportation budgets that can be leveraged somehow. So I would definitely encourage anybody out there to check out the Wildlands Network and the Center for Large Landscape Conservation. But those are just two of, again, many groups whose work touches upon this in some way.
Great. This question says, you mentioned insect kills, such as the monarchs. Are there any strategies that can mitigate the effects on insects? And I certainly notice many fewer insects smushed on my windshield when I drive.
Yeah. I mean, to the latter point, that the windshield phenomenon, right, is really, really well documented. We know that we're losing insects very, very rapidly, because of pesticides and habitat loss primarily. And so in that sense, like roadkill becomes this form of documentation, of understanding, the decline of these insect populations. As for mitigating insect kill, it's a tough one. I mean, I will say, let's see, a couple of things. First of all, fencing for insects does exist. That there is precedent for that. There's a very famous what is it? I think it's the purple crow butterfly. It's the second largest butterfly migration in the world after monarchs. It happens in Taiwan every year, and they actually put up these giant roadside nets for these migratory butterflies in Taiwan. And in some cases, during the peak of migration, they actually close the highway altogether to traffic. So it's like hard to imagine doing that in Texas during the monarch migration, right? But there is precedent for that. A couple other thoughts. I think there is stuff you can do around roadside planting. I touched on this briefly, but I've one idea that I've heard floated a lot, and I think has been tried successfully to some extent, is elevating plantings, right? So along the highway you build a big berm basically, and you put the milkweed up there so that, again, butterflies are flying over traffic rather than through traffic. There's some thought, there's been some research basically showing that, if you just plant roadsides thicker generally, your insects don't have to cross traffic as much, right? If all of the milkweed you need is on the south side of the highway, you don't have to go to the north side of the highway, right? And so, maybe if we have more densely planted roadsides rather than kind of patches, we can basically induce insects to remain on one side of the highway and not have to go through traffic. I mean, you do see some use of wildlife crossings by insects. There's somewhere in California, there's an overpass that is largely used by mammals, but part of the siting for the overpass was actually determined by this population. I forget exactly what checker spot it was, but it was some checker spot butterfly, some fritillary, and this low-flying butterfly that was really susceptible to being roadkill, and they basically planted that overpass in whatever that butterfly's food source was, and I'm not sure how well it's worked, but there is some thought there that we can use these overpasses as insect crossings as well.
Yeah. It's funny that you say that, because I actually had two things that came to mind as you were speaking. You said you're not sure how well it was, used, but did you find any roads or like any of the crossings weren't successful? Was there anything that was built and put in, but then was not really used?
Yeah, I think that, I mean, the first thing I'll say is that a well-designed, well-sited wildlife crossing gets used, right? There's
Okay.
like lots of research showing that, if we build these things right, they're effective. The problem is that, historically we didn't always know how to build them right, right? So, in the early history of road ecology, you definitely saw some ineffective crossings. The most famous one, or maybe infamous one, was the Toad Tunnel in Davis, California, that was built under, I believe, I-80. And there, it was just this like incredibly long, narrow pipe that, went on for like hundreds of feet that, there's no light, right? It was totally pitch black and dry. Like, why would a toad ever use it? And so, so Davis put in this toad tunnel. And then I think it was like mocked maybe on the Daily Show or by Stephen Colbert. It got all of this, kind of like derisive press because it was just, terribly designed, never going to get used. And I think that actually, unfortunately, did a lot to kind of like cast aspersions on the whole idea of,
Mm,
amphibian mitigation. So that Davis Toad Tunnel, that will always live in infamy as a very bad wildlife crossing.
yeah. Um, and can you speak a little bit to, how do they get the data or, how do they know what is using it, how many animals are using these crossings?
Yeah, it's a really good question. I mean, so the primary technique now is camera traps, right? Motion activated cameras along the crossings. Historically, prior to the camera traps, you would see what they called track pads, and you still see this somewhere, and especially in developing countries where there's not, just not a lot of money for cameras, where basically you'll put a bunch of sand on either side of the crossing. And then you just check it every day or so, and just look for those paw prints
Hmm.
in the sand, and then you can kind of like rake it clean every other day so that you're getting kind of a fresh data set. And then you also see a lot of DNA analysis too. A lot of hair snares, right? So you can stretch a wire along the crossing, and if a bear is walking by, a little tuft of hair gets snagged, and then you can do DNA analysis and actually identify that individual bear and
Mm,
figure out how it's related to the rest of the population, right? So in Banff National Park, for example, where they said, okay, we know that bears are mating on either side of the highway. And so we're refreshing that stagnant gene pool sufficient to save the population. That was how they figured that out, was through capturing those little tufts of hair and basically figuring out how all of those individual animals were related to each other on either side of the highway.
mm. Wow. It's really interesting.
Yeah.
I was also wondering about like conservation or preservation of the land around the crossings. Is there, I'm sure things can change, things can get developed. Is there anything that is put in place when they build the crossings that would ensure that um, the land around it stays intact for the animals?
Yeah, great question. A really important question. I think that's another reason that, Western states have done more of this historically, because we just have a lot more public land out here, right? We have
Hmm.
land that's protected in perpetuity by the Forest Service or the Park Service or the Bureau of Land Management. And so you can build an overpass between two blocks of national forest and be pretty confident that that's still going to be protected 50 years from now. Whereas in a densely developed or agricultural eastern landscape, right, that could be condos in a few years, and then you've got a bridge to nowhere. And so yeah, that thinking about that land tenure is really important. Often what you see are DOTs working with land trusts, right? So saying, hey, we're gonna acquire parcels on either side of this overpass, to make sure that's habitat. Permanently. But it is a really important consideration because you definitely don't want that bridge to nowhere phenomenon.
Yeah. Well, before I ask my last question, I definitely want you to know that a lot of the folks who tuned in tonight have read your book or
Oh,
are in
good.
the midst of reading your book, and
Fabulous.
gave a lot of great accolades to you. So I want you to know that those were
Well,
popping in here as well.
thank you guys so
Um,
much.
and I'm just curious to know what you're working on these days. Is there another book in progress or is there another topic that you're exploring?
Yeah, I'm writing a book right now about fish migration, which is why I always include some aquatic examples in my my road ecology talks. Basically, it's a book about how fish movement is this kind of incredible ecological and cultural keystone process that, of course, we've screwed up in a million ways, yeah,
Mm.
including with our roads, and are now trying to protect and restore and understand. So there are some so every chapter is about a different fish species or group of species, from Pacific salmon to, Eastern alewives to sharks in Florida, just trying to capture the incredible diversity of these amazing animals.
Wow. Wonderful. Well, best of luck with that. Maybe we'll have
Thanks.
to have you,
Yes.
maybe we'll
Spring.
have to have you
I,
back at some point.
yeah. I hope that'll be out by, let's say maybe 2 years from now. Spring of 28 is kind of the track we're on.
Okay, wonderful. Well, Ben, thank you again for taking the time to be with us tonight and sharing all this amazing information. Again, lots of people reading your book out there. A lot of people really appreciated all the information that you shared. So, thank you for being with us. And thanks to those of you who are still listening at this point. Thank you for all your questions. And hopefully, you'll join us for next month's lecture. All right. Take care,
Thank you all so much.
everybody. Good night.